Hello friends, in the series of learning aerodynamics, let us start to discuss some of the topics or some of the important aspects of the airplane performance. So airplane performance, when we want to start or discuss, first of all we need to understand the equation of motions of the aircraft. So generally we will just consider the aircraft which is in the inclined position, or okay, that is somewhat in the upward direction. So we can just say it is in the climbing position or something. So in this position, what happened? Lift and weight, thrust and drag, how it is acting. So that is matter. So because as the weight is acting through the CG, so it will be acting downward, but whereas lift force is will be acting that is perpendicular to the this flight path. So that is what happening here. So now this is the thrust force is subjected to the angle. So that angle we can just say as the climb angle, or this yes, climb angle, we can take it as the climb angle. So this angle and this angle and this angle, so all will be the same. So now if you are just finding the forces acting on this aircraft, so that we can write it as the summation of forces, or we can just say summation of forces, summation of vertical forces. First let us take summation of vertical forces equal to, so we have to say forces acting in the vertical direction. So when we are considering the forces acting in the vertical direction, that is lift. So lift into, so that angle is nothing but included angle, so it will be a cos theta. Then what happened, this thrust also is now having, or okay, having the angle with the horizontal axis. So similarly with respect to vertical axis, the thrust can be brought to vertical. So we can just take it as, this is theta, so this is included angle. So thrust is brought to vertical direction, that will be equal to T. So included angle will be taken as cos theta. So extended angle we can take it as the sin theta. So sin theta. Then just we have taken these two poses one side. Then other poses we can keep it on the other side. So that will be, we can take it as the negative. So we can just other side poses. So these two are one side. Then below the reference line, so we have other two poses. So that is W plus, we can just say this drag. So drag is now that is also subjected to the angle theta. So when we are taking in the vertical direction, this will be thrusting drag into sin theta. So this is, so these two components are one side, that is why positive, and these two components are other side, that is why we have taken the negative, common negative. So we can just say as the this one, this summation of vertical forces will be subjected to the we can say that is a mass into acceleration. So mass into vertical acceleration we can say. So this is what summation of vertical forces is. So equal to this, now we can rewrite cos theta plus T sin theta minus W minus D sin theta. So let us take it as this is equation number 1. Then we can write the other equation, that is horizontal forces. Summation of horizontal forces we can write. So that is summation of horizontal forces, that is equal to, so first let us see this side forces. So drag is also subjected to the angle theta. Then lift also, so we can take drag into this is included angle cos theta plus this will be taken one side, this component and this component taken to one side, so that is L. So this is okay, excluded angle, so L sin theta, so we have taken one side, so other side what is there, that minus, so we can take now other side only one forces, that is the thrust into, that is also subjected to the theta, thrust into cos theta, so we can just say cos theta, so we no need to put this because only one component is there, so this will be equal. Okay, so this is what we can say as equation. So similarly we can here also we can write, so summation of this is, we can write mass into acceleration, so horizontal acceleration we can say this will be equal to summation of horizontal forces. So this we can take it as the equation number 2. This equation 1 and 2 can be taken as the equation of motions. So equations 1 and 2 we can say as the 1 and 2 can be taken as the equation of motions. So these two are equations of motions. Equation of motions. So by using this equation we can derive the condition for steady level flight. So because this is subjected to the steady level flight, so we can just say this flight is nothing but steady level flight. Steady level flight. So in steady level flight, what would be the condition? Because now it is in the inclined position, so now if it is in the steady level flight, what happens? Steady means it is constant velocity, so level means at a particular height, so that is what we can say steady level flight. So with a constant velocity at particular height, so it is keep flying, so that is what a steady level flight. So in that case what happened, our acceleration is becoming 0, that means this acceleration is 0, then summation of forces will be 0, this component and this component. So in the case of steady level flight, so these components will be considered as the 0, that means for steady level flight we can just say so for steady level flight, so we can just say these forces, that means here also these forces and this because since there is no acceleration in the steady level flight, so this component will be 0, and this equation we can rewrite, and here also in this case also this will be 0, this also will be 0, so we can rewrite the equation. So when we are rewriting the equation, it will become that is like L, we can just say write L cos theta plus T sin theta minus W minus D sin theta. So here what happened, when the aircraft comes into the horizontal position, or it is in the steady level flight, what happened, this theta will become 0, so that is the idea, theta also is becoming 0. If theta becomes 0, then L cos alpha or L cos theta, so that will be we can take it as the 0, that means this also we can write it as, when we are applying cos theta, that means theta equal to 0, this condition, then this will become L. So this equation 1 becomes, so that means for the steady level flight when theta equal to 0, equation 1 becomes L, so this is L, and plus T sin 0, this is 0, then this is minus W, then this is 0, so that is 0. So it is equal to 0 because summation of forces this side, left hand side, will be 0. So we can just put it in the here. So this gives lift equal to weight. So from this we are getting lift equal to weight. Then from equation 2, so from equation 2 we can just say this, when theta equal to 0, so cos theta, cos 0 0, that is d. Then this component will become 0, then minus this t minus d, that is equal to 0. So from this we can say thrust equal to drag. So these are the two conditions mainly we are considering for the steady level flight. So in steady level flight, this lift becomes equal to the balances the weight, and thrust balances the drag. So okay, when lift and weight balances the when the lift and thrust balances the weight and drag, then okay, how the aircraft moves forward. This is based on the Newton's first law of motion, because if the object is in the rest, it will continue to be in rest, or if the object is in the motion, it will be continuing to be in the motion, unless it is disturbed by any external forces. So since it is in the motion, so it will be continuing as long as it is not undergoing any maneuvering, or it is not undergoing any kind of acceleration. So that is how the steady level flight works. And the equation also just we are getting, that means we are achieving this condition, lift equal to weight and thrust equal to drag. So rest of the performance conditions we will see it in the next class, and we will continue this discussion in the upcoming classes.